And the body is prepared for what we call a flight or fight stance. We are either going to stand up or fight, or you're going to run. Okay? And when that happens, you need energy. So what is the energy? Sugar. So the body internally starts producing a lot of sugar for preparation that you are prepared to either fight or run. Okay? So stress by itself can make you a diabetic. If you are a very stressful person. You don't have to be a diabetic per se, according to the other things but stress. Have enough sleep. You know, if you don't have enough sleep, you're not giving the body time to rest. Because think about it, the body is a machinery. It's working 24/7. You need rest. Or else there is going to be a malfunction sometime in that period of your life if you don't have proper rest. Okay? Next one, please. Okay. So this is some of the drugs that are recommended for type 2 diabetes. Because I said type 1, you know that you have to have insulin, you don't have a choice. But these are the drugs that are used for type 2. You have the sulfonylureas. Now again, you go to a doctor and they give you medication for the diabetes. But they never tell you how these things work. So the sulfonylureas, which is like glycoside, works on the pancreas. Now, again, you're making an assumption that the pancreas is still producing insulin. You have checked for insulin concentration. Nowadays, we have testing that we can do to test if you have insulin production or not. Okay? So that's the glycoside form, is to use for the secretion of insulin. Now, how do you take this medication? You hear most of the people that I talk to, oh, I take it before meals. Okay, that's good. So you take it before meals. How long before meals? That makes a difference. Some people take it with meals. Some people take it after meals. But you have to take it before meals, because remember, that drug has to get in the bloodstream, go and activate the pancreas, or stimulate the pancreas to produce insulin. Okay? So when you eat now, and that blood sugar goes into the system, the insulin is already prepared, or already packaged to work on your sugar. Okay? So that's how it works. Now the bioequivalence. We've reduced hepatic glucose production. Okay? So what does that mean? When you have glucose in your body, I said it flows through the blood. The liver normally takes up half of uptake of glucose. And the liver converts some of the glucose to glycogen. Once that storage is filled, the rest of the glucose is shoved back into the blood because it has to go to other places to make other stuff. And so it can rise in the liver and in the blood. So what this metformin is doing is preventing the production of glucose. Okay, or release of glucose in the blood. Also, metformin works at the cellular level. It opens up what we call the glucoporter, the glucose port, or the transporter of glucose from internally from the cell to out the cell membrane to move glucose into the cell. So it's very helpful in people who have insulin resistance. So you see that most people who are obese will be put on metformin. What you have to realize that this has to go to the cell to activate all the change. So again, this medication should be taken before a meal, maybe an hour, because it has to be absorbed, get to the cellular level, and then start making things happen in the cell for sugar to go in. So again, the timing is very important in terms of the medication that you give to the patient. You need to tell them exactly how to take this medication, not expect the patient to know how to take this medication. So all these are just different types of drugs that will help you in controlling diabetes. But look at this one. This is a drug that reduces glucose absorption. Now, to me, I would never ask someone to use that drug because you need glucose in your body. I told you 50% of our energy comes from carbohydrate. And that is the form when that carbohydrate is broken down into glucose in sugar. Our brain 24/7 has to have glucose. So if you don't prevent glucose absorption, what's going to happen externally? Your brain has to get glucose. So what's going to happen is that internally we will be breaking our amino acids to make glucose. And where does amino acid come from? The muscles. So internally we will start breaking down our tissues and organs to provide glucose. So this is okay, next slide. Okay, so type 1, type 2 was said to reduce food intake, exercise with or without drug or concentrated blood sugar. Next one, please. Okay, clinical results indicating control diabetes. So these are some parameters that can be measured in the lab to tell you if you have control diabetes. Like I'll tell you about the glycosylated hemoglobin, so if it's less than 7%, then you have control. I'll tell you that you have a control for 3 months period. Preprandial capillary plasma glucose. Preprandial means before, okay? Before the sugar. So 90 to 100. Postprandial means after, less than 180. So if you eat the meal, postprandial means that you eat and then you take a blood sugar. And then if it's less than 180, you have control. Blood pressure, less than 130 over 80. Lipids, LDL, low density like protein, less than 100 milligrams per deciliter. Triglyceride, okay? Now, LDL has to do with cholesterol. HDL has to do with good cholesterol and bad cholesterol. I don't want to get into that because I haven't taken all the these things. But people don't realize that, okay, they think that if you don't eat cholesterol or cholesterol food, you won't have cholesterol in the body. Well, that's a wrong thing here. Because if you eat a high-fat diet, triglycerides, they'll make cholesterol. Okay? So there's a possibility that you will always have cholesterol in the body because the triglyceride make it, and because cholesterol is such an important component, but that's this is a seminar for that. Okay? All right, go to the next one. So these are the clinical impact of having diabetes on control. Okay, this is what can happen to you. You'll have a 2 to 4-fold increase in cardiovascular mortality, leading cause of new cases of end-stage renal disease. And I'll come back to that just now in the next slide. The leading cause of new cases of blindness in working age adults. And that's where you have the say glaucoma. So when your blood sugar is very high, remember you have blood vessels of various sizes in your body. And so if you have sugar is a crystal. And if it gets very high, there's a tendency that when up to the small vessels, it blocks the vessels. So extremities, for example, that's where you have sometimes toes, not proper circulation, or fingers if the extremities not proper circulation, because the sugar blocks the vessels. And if the sugar blocks it, nutrients not getting to those extremities. And after a while, those cells dies in that extremities, and that's where you get the back you have to get application, right? And so in the eye now, the same thing happens because you have small vessels here. There might be a blockage here, and you have what's called glaucoma. Okay, so that's what we're talking about here. Okay, so this is a recommendation. Like if you know you are overweight, you should try to lose some weight, 5 to 10% of body weight. Now, how do you know if someone is overweight? Well, there's a formula there. Okay? If you're a male is supposed to be for each 106 pounds for 5 feet. If you're 5 feet, it's supposed to be 106 pounds. And for every inch after that, you add 6 pounds. So if you're a male about 5 feet 9 inches, you're supposed to weigh 150 pounds around it, right? Okay? So that's how we know. But again, it depends on your frame size. Not everybody is 5 feet 9 inches and have the same frame. So depending on your frame size, you have small frame, medium frame, or large frame, you will decide according to that what weight is supposed to be. So you go about 10% each way. If you're a small frame, you do 10% less. If you're a large frame, you do 10% more. Okay? So you have a range you can work with. And then based on the weight, okay, you can know how to make your menu for your meals. Because your body, the metabolic rate of what you use for a meal is 1 kilocalories per kilogram body weight per hour. Okay? So if you know that's your rate, your metabolic rate, you can make a menu to maintain that ideal weight. So what you put in, you utilize enough of that weight. And the timing is very important. Okay? Space fields to allow body time to utilize energy. So you're not supposed to go ice now. So if you're, as I said, if you're a 70 kilo person, you average that you're using about 70 kilocalories per hour. Okay? So if you put in 300 calories, that should last you about 4 hours. So in 4 hours time, you need to put another 400 calories. But again, not just empty calories, like I'll drink 2 soda pop, right? Or stop beers. You need to have a balanced meal. So all the nutrients are there all the time. Okay? A good thing to remember is to try to eat your meal last meal before 6 p.m. Because remember, the body is like a machine and it needs rest. And we work with the light and dark cycle. So when we have light, our body is more efficient. When we have darkness, our system slows down. Our metabolism slows down. Okay? So we can't eat the same food that we eat during the day in the night. Because the metabolism slows down, so that extra food is going to be stored as fat. And what is also important, and what is very prevalent in Guyana, is thyroid problem. A lot of people come up with thyroid or goiter, they call it. And they're not aware of that. So when people are obese, it's not because people are obese sometimes. It's because the thyroid is being affected. Okay? The thyroid is responsible for metabolism. And what does that mean? It means that every cell in the body, for it to work properly, the thyroid has to produce a hormone to make that work properly. So if the thyroid is malfunctioning, or if you have hypothyroidism, then you have a problem with metabolism. And that, by itself also, if you have low metabolism, nutrients are not going readily to the cell, you can raise the nutrients in the blood. And so the sugar can be raised indirectly due to a thyroid problem. And there are certain food that if you are eating very frequently, can prevent your thyroid from producing the hormones. The thyroid needs iodine to make its hormone. And there are certain foods like cassava, cabbage, that inhibits the iodine uptake. Okay? So if you're a lover of cabbage and cassava, there's a high probability that you might be suffering from a thyroid problem. You need to get that checked out. You have our natives. All your meals are cassava based. It would be nice to go and check, do a study there, research there, and see what their thyroid function is. So I know a colleague of mine, when I was working at UG about 10 years ago, this guy came from Boston. I did a survey in a place in Turkey called Firish. And he was telling me, he said, Dr. Ravana, do you know that this area is, has a high incidence of goiter? I said, what? He said, yes. There's a high incidence. When I did my survey, this is what I found. And people don't realize that there's certain foods that can contribute to the goiter. I said, cassava, so if you're a frequent eater of that. And that's why we have iodized salt. is to prevent the thyroid problem. Because they realize that the iodine is in short supply in certain areas. And without it, we have a thyroid problem. So that's why they put iodine in salt. So that everybody, because everybody uses salt. So there's some way you can have your iodine. Okay? So again, if you see moderate concentration of alcohol, and then the 3 P's, we need to get research on. Okay? Now, based on that, those are the normal recommendations that's given now. But my suggestion is my opinion, okay? And I like to better that. I do not think that the high blood glucose should be the only criteria for diagnosing someone as diabetic. Why did I say that? Well, when we do a blood sugar test, we are also surmising from that there's a lack of insulin. And that's a wrong interpretation. Insulin is the only hormone that I told you about hormone utilization. Okay, meaning that it moves things from the blood into the cells. But there's 5 hormones that counteract insulin actions, meaning moving things from inside the cell into the blood. Okay? And we are saying that when we have a high blood sugar, that insulin is a problem. And that's, I'm saying, that's a wrong interpretation. We need to do more in-depth testing. We have the tools to do that. How can we say, let's someone had health workers tell me that insulin is no longer seen in their consumption. This is a wrong assessment. Insulin is the only hormone that lowers blood glucose. But it's 5 hormones: glucagon, cortisol, epinephrine, growth hormone, and during pregnancy, placental human lactogen causes raises blood sugar. Okay? So, how do we know that if it's the high blood sugar is due to lactic acid? Well, if insulin is lacking, then not only sugar will be high in the blood, amino acid will be high in the blood, triglyceride will be high in the blood, because remember, insulin is the one moving these things into the cell. So all these values will be elevated. So that you can say there's an insulin problem. Now, if you have a high blood sugar and you have urea elevated, okay, or fatty acid elevated, then that is due to not insulin, lack of insulin, but some other hormone. Okay? Because when urea is produced, it's showing that there's a breakdown of amino acids and to make sugar. That's the only thing that urea produces. So that tells you that endogenously, the sugar is being produced and not coming from the outside. And you need to look at the other hormones that might be oversecreted, glucagon, cortisol, like I told you, Cushing syndrome. This is where cortisol will be oversecreted involved in So that needs to be looked at. We need to say, not to make the assumption that once you have a high blood sugar, that insulin is lacking. We need to do more in-depth testing and differential testing where you can say this whether it's insulin or some other hormone problem. If it's not insulin, then you have to go further and specify which hormone is causing the problem. Okay, as I said with the giants, we know it's growth hormone. Okay? Another thing, we can also test for insulin now. Okay? Maybe insulin test is too expensive, but there's an indirect way of knowing if you have insulin in your blood or not. Insulin, when it's in we call it inactive form, it's in a package with called proinsulin. And proinsulin is made up of 2 parts, insulin and C-peptide. And they are in equal concentration, like sodium chloride in that to know the top concentration. So if you do a testing, you can test for C-peptide. If you find C-peptide in the blood, you know that insulin is there also. Because indirectly, whatever amount of C-peptide you find, you will find that indirectly insulin also. Because C-peptide is only released when you have the breakdown of proinsulin. Okay? So once you find that, if you don't find any C-peptide, then you say there's a lack of insulin also. So indirectly, you can get a value for insulin by measuring C-peptide. All right? Another thing I want to say, we have been eating a high-powered reliable meat for decades. we don't have a high blood glucose as compared to individuals who eat a low carbohydrate diet. Our standards were formulated from a low carbohydrate scheme. And this is what happens. We are using standards that are made for Caucasian people. They were made in the European countries or the white people are North Americans. And those standards don't apply to us. That's temperate climate. We're in a tropical climate. Our lifestyle is different. Our eating habits are different. We have been eating for decades a high carbohydrate diet. So our tolerance for carbohydrates should be higher. And that's the example I give you. They have Eskimos live in the North Pole. And they eat what we call seal meat, flowers, fat, a high fat diet. And they don't have a single cardiovascular disease. Okay? So same with us. Our sugar will always be a higher value than the North American people. Because in North America, we do those standards. Those people are eating a high protein, low carbohydrate diet. That's why they have a high fat meat. Okay? They eat a lot of meat. So they grow up and having a low sugar. Okay, put it that way. Our blood sugar will always be lower than us. Why are we not making our own standards? So we need to revisit those kind of difficult values. Another thing I like to mention here is that we are saying that our normal standard is 46 millimoles. But our blood can handle 10 millimoles of glucose. That's when it becomes saturated. Why are we dropping our blood sugar to 4.6 when the blood is saying that it can take 10? Okay? The blood has concentration for every nutrient that it carries around. Now, the kidney, remember the kidney filters things around. So when blood goes through the kidney and filters through the plasma, the kidney has sensors. So you give a medication to lower the blood sugar. When that low blood sugar goes to the kidney sees it as abnormal. Because as far as kidney knows, it's supposed to be 10 millimoles. Okay? That's fine. That's fine. And so what the kidney do? Try to reabsorb sugar. So every time you try to lower the sugar, the kidney tries to reabsorb. So what you put in extra stress on the kidney to work. And I'm sure that if we do research, we'll find that what's happening, that part of our kidney problem has to do with overwork in the kidney. We have in our body several mechanisms that works in coordination to raise our decreased levels. And we need to look at those things. We need to give our body time to respond. We're not supposed to just take things that happens right away and go to a doctor and take medication.